Hey, this is a really short lecture just to introduce some ideas to you as you're getting ready to start your class or your lab on clastic and chemical sedimentary rocks. So, as you learned in your first section about tectonic setting and how tectonic setting influences the sediment characteristics of an environment, I wanted to tell you that there are just a couple different types of tectonic setting that can influence depositional environment. So in mountainous regions or regions where basically rivers are draining mountains, you will tend to have what's called a Soliciclastic system. So as the name implies here, clastic means grains and silicic means grains dominated by silica or quartz. And so this is a picture of a couple different sedimentary environments that you would see in a Soliciclastic dominated system. When you're in level topography that's really, really far away from a source area, you'll have a carbonate dominated system and you'll be more likely to get limestones. But in a Soliciclastic dominated system, also sometimes called a silicic dominated system, you'll have environments that are characterized more by gravel, sand, silt, and clay. So, as you know, not every mountain range is the same distance from the sea. And so there are some characteristics that you might see in systems that where the source area is a really great distance away from the sea. And then there are some environments where you'll have mountains very, very close to the sea. Like you can think of some places in, anywhere where you have volcanoes near a coastline for sure. This would qualify. Or a lot of places around the Mediterranean Sea also have mountains very close to the sea. So when you have mountains that are, even if they're far away from the sea, they still have a tremendous number of rivers and sediment being transported away from those mountains, you'll tend to have environments called alluvial fans at the base of those mountains. This is really like a triangular shaped feature where you have small little streams that drain the mountains of sediment. A lot of times alluvial fans, there will be small little braided rivers on alluvial fans, and you may, especially in glaciated areas, have a series of braided rivers as well. Braided rivers typically organize into one large main stem river. Very often this is a meandering river. So sometimes you'll have sediment deposited within the channel, sometimes on the point bar of the river, and sometimes on the floodplain, like adjacent to the river. Sometimes there will be barrier islands or long, narrow islands that are parallel to the shoreline. And in between barrier islands and the mainland, you'll have a lagoon. A lagoon and a barrier island are considered sort of a transitional environment because you're transitioning here from the continent to the sea, where rivers will flow into bodies of water. You'll have deltas. Sometimes you'll have flat areas where the tidal range is significant, which means, and you'll develop tidal flats. Tidal flats are sometimes inundated by the ocean and some during high tide, and then are exposed during low tide. And these tend to be quieter water environments where you have a lot of muds that are deposited. Certainly you'll have desert dunes if the environment is right. And then you have your continental shelf, which is actually technically part of the continent, and it is partially, in this case, fully inundated by the sea. And you'll have a series of sedimentary environments that you'll find here that we'll talk about more this semester. If you get far enough from the land, but you're still as part of this system, eventually you will get to environments where you'll have carbonate material deposit. Carbonate material like calcite will only form in environments where most of the silt and clay has already been settled from the water, and you can start to have the precipitation of carbonate. And sometimes that'll build up in structures known as carbonate reefs, which are going to be obviously mostly stabilized by the presence of coral as well as other fossils that you'll learn about in the next coming weeks. The other thing I wanted you to see is that when you're in a long system, like you see here, there's a great distance for weathering to occur. And as weathering occurs, we know that minerals start to weather away if they are unstable at Earth's surface. So the sediment that you'll see at the beach here in a long system is predominantly quartz in composition. And that is going to be different from when you are looking at a system like this, or a short system, where you have the continental slope or the continental margin here very close to your source area. So here, there's not a great distance for weathering of sediment. And so the rocks that you tend to form here are really rich and they'll largely turn into gray wackies. And again, you'll have alluvial fans at the base of those mountains. And we'll learn more about the topography of the shelf and slope later on in the semester. So I just wanted to introduce you to some of these terms because you're going to be using them shortly. So in an environment where you're very far away from the source area and you don't have a lot of sediment, you have lots of limestones and dolostones that tend to form, and sometimes cherts. So there are lots of different limestones that you'll learn about this semester than you were aware of in 101. There will be areas where limestone will form above the high tide, and you'll get features like mud cracks. Then there will be different features and rocks that will form in the intertidal zone. So again, this will be between high tide and low tide. And this will also be this is a tidal flat area as well. When you have a barrier island or a reef that pokes up above the surface, again, in between land and that barrier island, you will have a lagoon, and you'll learn about some of these terms a little bit later. A patch reef is really just a small reef. A stromatolite is a structure that we don't see a ton anymore, but they're actually some of the earliest forms of blue-green algae or cyanobacteria that are responsible for a lot of the oxygen in our atmosphere today. And then we have this barrier of a barrier reef where you have a reef structure that actually pokes up above sea level, where you have sloshing back and forth of sediment in really carbonate-rich water. A lot of times you'll have these little spheres called ooids form, and ooids are found in a rock called Oolitic Limestone. They are literally little balls of calcite that form during times when there's a ton of dissolved calcium carbonate in the water. And again, further out, then you can see more patch reefs. And deep shelf and basin are exactly what you think they would be. They are below the depth to which waves agitate, and you still can have carbonate material there, but it turns out that it'll be much finer grained in general. Okay, so that's just a really brief introduction to why we have chemical carbonate and clastic sedimentary rocks and how that relates to the environment in which they formed.